how they help us determine whether these triangles are congruent. Okay? And so we're going to give you, there are four ways to prove a triangle is congruent. Today we're going to do two of them. Okay? We're going to do two of them. The first one. The first way to prove triangles are congruent is side, angle, side. Okay? Side, angle, side. There are four of these. You just need to write down four ways in your notes. And this is the first one, side, angle, side. You'll see our drawing here. And you'll see that there's a side and an angle and a side. Is everybody? Somebody tell me something that you see about that angle. Where is that angle located? Where is that angle located? Anthony? If you look at this, where is that angle located? You see it? Where is it located in relation to that triangle?
Q.
It's Q, but what else do we know?
That's a.
Here's a side and here's a side. Where is that angle? Is it outside of it or in between it?
Outside.
So that angle is outside of this line and this line.
Oh, inside.
It's in between, right? So it's important, okay? So look at it, read our drawing. If two sides of a triangle include an angle, then the corresponding sides, these two sides are congruent and includes the angle, then the two triangles are congruent. If that's true, then those triangles are congruent. Does everybody understand this? So we have our triangle here, okay? We have our triangles, and we realize that this angle must be included. Now, Brandon, I want you to come to the board. Brandon, come to the board, and I want you to draw another set of triangles that demonstrates our side, angle, side postulate. Come on up, okay? That will demonstrate that. So take that marker there and draw us another set of triangles that kind of looks like this, but demonstrates it differently. Everybody else follow along. Let's see if he gets it right. Good. Well done, Brandon. Does everybody agree? Is this similar? Mm-hmm. Does it work? Why does it work? Because what? The angle is what? Included. Does that make sense? Is everybody seeing this? Mm-hmm. The angle's included. Great job, Brandon. Well done. Okay, so this is important. The location of the angle is important. Why do you think the location is important? Anybody have an idea why the location may be important? Give me something critically why it could be important. Think about it. This angle and this angle. It's determining what? Would it determine this side? Yes or no?
Yes.
It would. Good. So that's the reason that location is very valuable, right? Good job. All right, now let's look at the second way, and we'll kind of tie these in. We'll use some information here and tie it together. But we're going to do the second one. Here's the second one. Angle, side, angle. Angle, side, angle. And here's the definition. I'll read it for you, and then we'll go over it. If two angles and an included side. So now it's different, right? It's talking about two angles and an included side. Okay? Are congruent to corresponding two angles and the included side, then you have two congruent triangles. All right? Two congruent triangles. Now, does everybody see that? Everybody look at our drawing. We have an angle, and a side. Notice that the side is included between the two angles. Does everybody see that? Mm-hmm. Now, I want Kenya, I want you to come to the board, and I want you to draw another illustration, not this one, another illustration of this possible postulate. All right? Erase this one. Go ahead. Do it.
Wait, I just do this.
Change it. Yeah. So it's a possibility, right? It's another possibility. Can you draw a set of triangles that are together? So I want them to touch each other. All right, so ones that intersect. Keep going. Just draw like that.
Like,
Yeah, perfect. Now, label it. Remember, where's the side have to be?
oh, in between.
Exactly. Go ahead. Good. Well done. Class, let's give her a round of applause. That was really good. That was very difficult. All right, did you see what she did was she has our angles, right? And the side in between it. This side didn't matter at this point. It may matter later, but it didn't matter here. So well done, Kenny. That was really well done. All right? Now, so let's think about this. Why does it matter the location? Here's the key. I thought about this for integrating this into the Bible. What's the key? What's the key for us as Christians? It's the location of Jesus Christ in our life. Because if he comes into our heart and saves us, what happens? We're a different person. We're a new creature. And listen carefully, here's how it works. If this side is not located in the right spot, this doesn't work. If Christ is only in your mind, it doesn't work. But if Christ is in your heart, it will change you. So that's the integration, how this will work. Now, let's think about this for a second. If those triangles are congruent, what do we know? If the triangles are congruent, what do we know? We know one thing, and that was the last thing we reviewed before we got into the lesson today. What was it? See? Go ahead, Genesis, say it louder. Corresponding parts of congruent triangles are congruent. If they're congruent, then all the parts of them are congruent. Is that fair? And that's what we discover after the fact. Now, so let's go into this. Let's do an example, okay? All right, you guys are doing really well. You're doing really well. Let's do the next example, all right? So, looking at our drawing, here's example number 1. What additional information is needed to prove? What additional information is needed to prove that triangle C, A, B, so follow it, is congruent to C, E, D. So what information is needed if we're going to use side, angle, side? What information is needed? Danielle? So we have AC, right? Everybody see that? We have AC and CE. Is everybody good with that? And we're good. So we have one side, right?
Yeah.
What else do we need? What other information do we need? We have a side, we need a angle. What angle would be congruent? Angle C, right? ACB and DCB, why? They're what? Vertical angles. Okay, so now we have a side, we have an angle, we need another side, yes?
Yeah.
Okay, so maybe DB or CB, right? Everybody see that? CB and CD, right? Those would have to be congruent. All right, so if you look at this, you will see, we already said these are vertical, right? And we need DB, we need this also to be true, right? And that would then determine it. Does that make sense to everybody? Does everybody understand it, see it? So when you're using side, angle, side, you need a side, an angle, and a side. Is that fair? So let's do this according to angle, side, angle. What information do we need? We have a side. What do we need? We need two angles, right? So if we pick this angle right here, which is ACB and DCE, everybody agree with me? Those are congruent because of vertical angles. What other angle has to be congruent, Chris? What other angle must be congruent? If this angle here is congruent, these two here, and we're going to use angle, side, angle, and the side is included, what angle would we have to use? So these angles are used right here, and this is our side, right?
Right.
So what angle would be the one that would make it so that side would be included?
BAC.
With this angle here?
Yeah.
Angle A and angle
D.
good. Angle A and angle D. Does everybody follow this? Everybody good?
Mhm.
I mean, let's watch it. Let's watch this real quick. ACB is congruent to DCE. Okay, so that's true because of vertical. Watch how they're labeled. Then what? We need angle A. I'm sorry, angle A and angle E. Why these two? Because of what? Because those are the ones that include your sides. Okay, so make it so that you're including the side. All right. Everybody follow me?
Yeah.
Sir.
All right, good. Here's your important part that you need to remember. All right, this is important for you to remember. 1, triangles cannot be proved. They cannot be proved using side angle. You cannot prove it to be true according to side angle. All right. The other thing that's an emphasis point is this. After two triangles are shown congruent, then every part is congruent. Why? Because if they're congruent, then all their parts are congruent. Does everybody understand this? And you'll get this information, so you don't have to make sure everything's written down perfectly, okay? You'll get this information from me, all right? Let's do one more thing here. We'll do another example real quick. All right? Okay? This example is a proof. So everybody look at our drawing up here. What do you see? What do you see marked so far, Natalie? ML and
LO are congruent.
good. And you also see, what else? What else do we see marked, Danielle?
Triangle angle LNN and angle LON are congruent.
So these two angles up here in the top corner are congruent. Does everybody see that? So if we were to do this up on the board, here we go. Here's what we have. Everybody see this? Everybody agree with me so far? Now, what's the reason? A given. Now, what can we see? What do we need? Now remember, what are the two ways to prove triangles are congruent? Side angle, side, and
Angle, side angle.
so side, we have a side, we have an angle. So we need to have an angle or a side. Does everybody agree with me? What do you see is common in both triangles, Sarah? LN is common in both. Can somebody tell me what equivalence relation tells us LN is congruent to LN? Chloe? What equivalence relation? Which property tells us that LN is congruent to LN?
Angle?
No? Jenna? Reflexive. Good. Reflexive property. So our reflexive property. Okay? So what we have is we have our reflexive property. Alright? Now, so that means if we were to do our marker drawing, that would give us a side here, right? Can somebody tell me what makes are these triangles now congruent?
Yes.
Side, angle.
Side.
Alright, good. So what's the reason?
Side,
Angle,
side.
side.
Good. Everybody got it?
Yep.
So you just did a proof in 5 seconds. You guys are doing better than I would ever have done, alright? When I was in high school. Alright? Now, it wanted you to prove that M and O are congruent. So, if the triangles are congruent, what do you know about M and O? Why?
CPCTC.
There you go. Does that make sense? Does anybody have any questions? Does it make sense to everybody? Awesome. All right, good. So let's go ahead and let's just do one last thing. Here's your homework. We're going to go over the homework real quick. Your homework is here, page 165, 161 to 16. Now, here's what I'd like to do very quickly before we do that and finish. Okay? Hope, I'd like you to come to the board and do number 8 so that everybody understands how to do these problems. Genesis, I want you to come to the board and do number 7. Everybody else in your seat, do number 7 and number 8. The left half of the room, do number 7. Right half of the room, do number 8. So you guys over here, Devin, your group over here, do number 8. And then we'll go over them and make sure we all understand how to do them. say why, you just need to say which ones. Just do the markings.
No.
Yep, yep, do the markings, and then what do you know?
Oh, I have to write
It's
that.
common in both. So what makes those two triangles congruent?
Oh.
What makes those two triangles congruent? What angle? Good, so write that. So we look at this, you have it drawn. What tells me, what makes these congruent? Side, good. So now you write that. All right, everybody look up here quickly. We have two done here. Let's look up together. Look at number 7.